Hello, my name is John Upton and I'm a researcher at Teagasc Moor Park. The title of this talk is Increasing Energy Efficiency on Dairy Farms. We'll get straight into the energy costs of milk production. Over a number of years, we've carried out multiple energy audits on commercial Irish dairy farms, and we've come up with the average electricity cost figure of €5 per 1,000 litres of milk sold. At a herd level, that's roughly €5,000 per 100 cows per year. There's a very large range within that, from €2.50 at the lower end of the scale up to €9 per 1,000 litres of milk sold. So if you could take one thing away from today's talk, it would be to figure out where you stand within that range. Because if you're at the higher end of the scale, there's a lot of money going to waste every year. Now, in addition to those average figures, we also have the component breakdown within those farms. And on average, we're seeing milk cooling being the largest energy user at 31% of the total. Water heating is next at 23%, followed by milking machine at 20%. The other there, the purple portion, the 18%, is the winter sheds, the compressors and the workshops. The water pump is 5% and the lights are 3%. So unfortunately, there's no silver bullet to get you from the higher end of the scale to the lower end. It takes an effort both in terms of management and technology to achieve that. Now, luckily, there are a couple of easy wins which we can talk about. First off, the more nitrate electricity you use, the better, because it's half the price of day rate. Nitrate kicks in at 12 midnight to 9 a.m. in the summertime, or right now, in the wintertime, it's from 11 p.m. to 8 a.m. And it makes sense to do as much water heating and the morning milking on nitrate as possible. In addition to that, it's important to check what supplier you're on and benchmark your unit rates every 12 months. I just checked this morning. There's a difference of €1,200 per 100 cows between being out of contract right now and being in a contract for 12 months with the cheapest supplier. And I'd recommend using a cost comparison site such as bonkers.ie to carry out that benchmark. Now, we'll speak a bit more about the technologies that can be deployed to tackle the main areas of energy consumption, starting with milk cooling. Now, the plate cooler is the best way to reduce the energy costs of the milk cooling system. The plate cooler simply chills the milk using well water before it goes into the bulk tank using a simple plate heat exchanger like the one in the photo. The goal of pre-cooling is to cool the milk to within 5 degrees Celsius of incoming water temperature. So for example, if your well water is at 10 degrees Celsius, you should be putting the milk into the tank at 15 degrees. And it's simple and easy to check that with a thermometer. Now, about 70% of Irish farms have plate coolers in place, but I would say don't assume it's working correctly. Make sure you get a hand on your thermometer and check out those temperatures. Now, to achieve that level of performance, you need to make sure you have a milk to water ratio of 1:2. So for every litre of milk that goes through the plate cooler, you need to be putting through 2 litres of water. Now, pipe size is important to achieve that, and also it's important to have a variable speed drive milk pump because it smooths the flow of milk through the plate cooler. Effective plate cooling can reduce cooling energy use by 40%. We'll speak in a moment about the return in terms of payback and CO2 offsets as a result of these technologies. Now we'll move on to the milking machine. The vacuum pump makes up the lion's share of milking machine energy use. And using a variable speed drive, or a VSD, can reduce the energy consumption of the vacuum pumps by 60%. This simply reduces the pump speed when demand for vacuum is low, and then it ramps up speed as needed in periods of high demand, such as washing, cluster attachment, or unit fall-offs. Moving on to water heating, and before we come to the efficiencies, we'll just mention the requirements. So, ensuring adequate supply on the farm is the number one rule when it comes to water heating. And you're looking to heat 10 litres of water for every milking cluster to wash the milking machine. So for example, if you have a 16-unit milking machine, you're looking to heat 160 litres of water to wash it. On the other hand, for the bulk tank, you're looking to heat 2% of the volume of the bulk tank. So as an example, if you had an 8,000 litre bulk tank, you'd need another 160 litres of water to wash it. So that would be a total daily combined requirement of 320 litres to wash both. Now, in terms of the cost of heating that water, so energy prices have increased a lot over the last 12 months, and therefore the cost of heating water have increased along with it. So for day rate, to heat 100 litres of water on day rate electricity would cost €2.23. If you can switch that over to night rate, it drops to €1.06. For gas or LPG, it's at 95 cents. And for oil, specifically kerosene, it's 90 cents. So you can see that the night rate gas and oil are not too far apart in terms of costs. Now, a lot of farmers are moving over to oil and gas for convenience purposes. However, we'll mention later on that the electrical water heater can be a useful energy storage device on farms when deploying solar panels. So no matter what type of heating system you have on your farm, heat recovery is the best way to reduce the running costs of it. The heat recovery technology is quite simple. It removes heat from the milk cooling process as it's operating, and it transfers that heat into a tank of water using a small heat exchanger. This technology can be fitted into existing tanks or can be installed at the time of changing the bulk tank. There's a TAMS grant available for it, and it will consistently reduce water heating costs by 40%. It achieves this by preheating the water to between 40 and 50 degrees as the bulk tank is running. And it will work effectively whether you have a plate cooler or you don't have a plate cooler. So the final piece of technology I'll mention today is the solar photovoltaic panels, or PV panels. These panels generate renewable electricity from the sun, and they're a very effective means of displacing fossil fuels and reducing energy costs on dairy farms. They can be installed on the roof or they can be ground mounted. The critical point with these PV panels is to size them for self-consumption. And I have a guideline there of 9 kilowatts of panels per 100 cows. The reason for this is because we don't want to export too much power to the grid, because right now we won't get paid for it. Now, there is a notion that we will have a small export tariff starting from January 2022. However, it's likely to be at such a low level that it won't justify too large a system on your farm. In order to maximize use within the farm gate, it's important to build in some energy storage on the farm. And as I suggested earlier, the water heater is an ideal way to soak up that power that's generated by the PV panels in the middle of the day. Alternative options for energy storage could be ice in terms of an ice bank, or also in batteries. To give you an idea of the order of magnitude of cost, the water heater can store energy at a cost of about €40 per kilowatt hour stored, whereas batteries would be 10 times more. There are good grants available right now for solar panels under TAMS up to a maximum of 11 kilowatt peak. And there's also the Accelerated Capital Allowances Scheme, or ACA for short, which allows you to write off the cost of the full investment in the year of purchase, which can be beneficial for people paying tax in the higher tax bracket. I'd encourage you to speak to your accountant about the effect that that might have on your farm. So we'll move on now to the payback periods and the associated CO2 savings on an example 100 cow farm. Starting with the plate cooler, we're seeing very low paybacks with the plate cooler, typically from 2 to 3 years, depending on whether or not you can apply for a TAMS grant on them. And they will reduce your carbon footprint by 2.5 tons of CO2 per year. The variable speed drives will have a payback ranging from 5 years to 8 years. It's normally closer to 5 years for 3-phase farms because the cost of installing the VSDs is much lower on 3-phase relative to single-phase. On single-phase, the payback is likely to be closer to the 8 years. And these will reduce your carbon footprint by 1 ton per year. Moving on to heat recovery, the payback is typically 4 to 5 years, depending on whether or not the TAMS grant is drawn down on it. The CO2 saving per year is 1.6 tons. And finally, the solar PV panels. They range in payback from 3 to 8 years. It will be close to 3 if you can avail of the TAMS grant and the ACA scheme. In the absence of those, the payback would be 8 years. The CO2 saving is 4.5 tonnes per year. So in total, that's a total carbon reduction of 9.6 tonnes per annum and an average blended payback of around 5 years. Now that's at current energy prices, and as we know, energy prices are trending upwards. Now that's not to say that all of these technologies would be relevant to your own farm. Some may suit better than others. To answer those questions, we have developed an online tool called the Dairy Energy Decision Support Tool, and it's available to use for free at the link on the screen. This tool can provide more farm-specific advice in relation to these technologies for your own farm. And just as a final parting word, we've seen that it's very achievable to reduce on-farm energy use by 50%, with 20% coming from the efficient technologies and a further 30% from the renewable technologies. And also, in a lot of cases, if the available schemes are availed of, the payback of doing so can be very good. So I'll leave it at that, and thank you very much.